All right, I think we're live.
Yeah.
All right. Rob Ward and Michael Collins with Pendant Automation.
Hey guys.
I'm Rob. That's Michael. And we're doing a video series. Hopefully, it's more than just this first one. But for the first one, we just wanted to get kicked off with photo eyes. And generally, we take it for granted that everybody knows what a photo eye is, and everybody knows how to use them, and they know when and where to use them. But the older we get and the wiser we get, we realize that that's not actually the case. And so we thought it would be fun for us and hopefully informative for you that we put together a video on photo eyes and going through the different categories and makeups of a photo eye, like wiring, mounting, common uses, operation, and hopefully in hopes of bringing us all on the same page at Pendant, and then, having the opportunity to share this with our integrator partners as well, just to make sure we're all on the same page with what's going on. And so to get this kicked off, let's just go back to the basics, and if we can answer one question, what is a photo eye, essentially?
So photo eye is a photoelectric sensor, so we've kind of shortened it to be photo eye. And it is essentially an optical sensor that looks at the reflection of its own light coming back to it and detects the presence and or absence of its own light in its reflection to pick up the change in an object's presence, for lack of a better term.
Yep.
Most photo eyes that we use have a light beam or an emitter, right? And the light would come out of the photo eye and it would bounce off a reflector. Right? And those reflectors, then the light would come back to the receiver, and that's essentially always happening. It's always sending out a light beam and expecting a light pulse to come back to it. So photo eyes can come in a variety of different shapes and sizes. If I switch over to kind of your screen here, you can kind of see, we have a typical photo eye like we might use on basically our standard photo eye, which is the 42EF photo eye from Allen Bradley.
Mm-hmm.
The nomenclature can vary, but just for the kind of sake of argument, that's what we have here. And then you have a whole bunch of different form factors, like this photo eye here. Right. It's designed to look between some rollers.
Yeah,
so it's
exactly.
It's
so
very
it's
narrow.
Essentially the same photo eye, just the form factor of it is built for a particular purpose, and that is to sneak up on MDR, a close roller conveyor belt, or something like that.
Yep, absolutely. So if you look at kind of those three photo eyes, they're doing the same exact thing.
Yep.
All of them are going to emit a signal via light and receive a signal.
Right, and those are all fully contained also, which means that you look in the optics of the one pointing up and you see there's two lenses, one of them which would be doing the emitting and one which would be doing the receiving in that same photo eye. And as we'll talk later, that's not necessarily the case with the through beam photo eye, which you only have one emitter and one receiver. Now, a common misconception that I want to talk about real quick is photocells. And so a lot of people at their house, maybe for their post light out front, they have a photocell on that, and that is not exactly a photo eye, because really all that is a receiver of sunlight, and it does the switching when sunlight is present. And so it's not really what we would call photo eye, although a common misconception is that is a photo eye. And so it doesn't work exactly the same way. It doesn't actually emit any of its own light.
One photo eye that is commonly found in the house is the sensors that are at your garage door.
Yep. Yeah. So those are through beam.
Yep.
That's a good example of a through beam photo eye. Garage door sensors, where it has to shoot that beam from one side over to the other, and it has to receive that. And if you break the line, then your garage door will not lower. Yep. And remember, we'll get to it later. So actually, I want you to bring that up when we talk about mounting, because the mounting is critical in photo eye placement. Because, for instance, that photo eye at your garage door is always mounted about 6 inches off the floor. And technically, if you had half of your car in the garage and half of it out, it would still shoot underneath of your car. Yep. And you could essentially still close the garage door right on your car. And so I know that that's an extreme and that's a funny um, example, but that's true that the mounting has to be given extreme consideration, as we'll talk about here.
I do it all the time. I'll press the down button on the garage door and then I'll run out and I'll kind of jump over it so it doesn't sense me blocking it.
Everybody does it, right? If you're a human being and you're 30 years of age or 20 years of age or older and you haven't closed the garage door and then ran and jumped over it to see if you could make it, then you are not truly living.
Exactly.
At
I feel
all.
the same way.
Yeah. So
I pulled up a document that shows a little bit of the different sensing styles for some of these photo eyes. The first one was just what we talked about, which is the standard, emitter receiver built into the same body.
Right. And retroreflective, right?
Yeah, retroreflective. So
moving on to the second topic, let's talk about types of photo eyes and why some of them might be better than the other. And so can you zoom in on that top one there?
Yep.
And then so retroreflective is one that we don't actually use here at Pendant, or at least we try not to, and for reasons that we'll discuss.
Mm-hmm.
And so do you use those in your experience, the retroreflective?
So it's funny. One of the things we're going to talk about is some uncommon uses, and I've used some non-polarized retroreflective sensors for uncommon uses. The problem with an unpolarized, you want me to switch to the screen?
Can you pause it real quick?
Yep, absolutely.
Yeah.
Let's see here.
Yeah, so retroreflective, like I mentioned earlier, we used to use those exclusively, and to an extent we still do, but the problem is, and we'll talk about them both in sync. So polarized retroreflective and retroreflective are practically the same eye with one caveat, and that is the polarized ones, they actually need to see the light beam be altered by a 90 degrees, which the reflector does. Mm. And the reason that we use the polarized reflective is when you have a package, let's say we used to use the regular retroreflective, and if it had the right if the tape had reflectivity or the package had reflectivity and it sent that light beam back into the photo eye, could give you a false trigger.
Actually, in fact, that's what they use some of them for, is tape detection. In some case sealers, they use a non-polarized,
so like a standard retroreflective
to actually read that the tape is there. So they use it for tape sensors sometimes, or
not
clear
know
object
that.
detection.
Yep, I like that. And so, yeah, exactly, clear object detection. So at Pendant, it's our standard and a default. We always use the polarized retroreflective. All of the reflectors are generally the same if you buy them from Allen Bradley, which we do, but it's just peace of mind that you're not going to get false triggers based on the package. You just never have to think about it, right? Mm-hmm. And we used to get calls all the time where the customer would send a box sideways and the tape would catch and it would look like two boxes when it was one, and it's just not worth it, right? Pay the extra 10% or whatever for peace of mind and use the polarized retroreflective.
Absolutely. When you're out there troubleshooting while you're trying to track the leading edge of a product, and every now and then you're getting two blips, you're going to wish you paid that extra buck or two for that.
And sensor. I guess, I can't stress enough that it only detects that light refracted 90 degrees coming back into it. And so a non-reflector is not going to do that.
Yep.
And then so moving down on the list, the clear object detection is pretty much the same thing as the polarized retroreflective. It's looking for that light pattern to be altered, which is something that it's going to distort it. So like the light's going to still go through that clear object, but it's going to get distorted when it comes back. It's not going to be that pure 90 degrees out of phase with each other.
Yeah, it's almost like a game.
Exactly.
It still might get back some of the light because it's a clear object, but it does pick up that that's not all of the light returning to it.
Yep. And then moving down to fused, and I'm going to ask you, I always get I can never tell that I've oftentimes used them interchangeably, although they are absolutely different, diffused and background suppression. Can you explain the difference between a diffused eye and a background suppression?
Yep. So if you are using a diffused sensor, sometimes it is hard to adjust the distance that it's sensing from the edge of the sensor to your object. So in a background suppression eye, it's smart enough to pick up a static background. So if, for example, I had this eye looking flat at the table, it is able to suppress this static background and still pick up the presence of an object passing under it. Instead of trying to adjust that gain to a finite position, let's say I'm trying to sense something that's half an inch tall, right, with a diffused eye, that finite level of adjustability might not be on that little potentiometer. So if I don't get a background suppression diffused eye, I might never be able to pick up a flat. Or
would it be safe to say that you would use a diffused eye when you have no background to look against, and no background also means you can't mount a reflector easily, right? Because you could be looking. We do this a lot, actually, and you're the one that taught this to me. But a diffused eye looking up. So you put the eye in between the rollers of the conveyor and it's looking up into nothing. And you have no background, you have no area that you can mount a reflector. And so you must have that type of photo eye. So you would use a diffused eye with no background, or when a background's not possible.
Yep.
And background suppression is essentially better than a diffused eye, but you need the background to have it reflect off of.
Yep, and I've never tried a background suppression diffused eye without a background, because it's usually I don't want to spend the extra money if I know I'm not going to have those finite constraints. But yeah, I wouldn't go with that kind of option on that sensor if I was just looking up through, say, the bottom of a conveyor. So it's actually, if I were to be able to share our screen again. So this guy right here is actually a diffuse sensor. So it is picking up, it is emitting and receiving light off of a fixed object without the reflector. So this one that looks up between the rollers is diffused. Like you said, back in the day, we would put a sensor straight up to the rollers like that.
Yep.
Right? But the problem with that in a normal conveyor application is you get dirt and debris that actually accumulates on this lens here. And it actually will cause it to start picking up that dirt and debris. So every now and then,
or it just covers it,
it completely. Yeah. So when you look at this, because it has such a severe angle, it's really hard for the dirt and debris to stick on this side.
Well, is there also dead space on a diffused eye? Like it won't pick up something within that too close to the eye?
Absolutely. So just like any optical system, it has what we call optical throw, which is the distance away from the, let's call it the surface of the sensor that it starts to read. So if, for example, the whole window for this eye was, say, 6 inches, that window might not start until 2 inches away.
Right. Okay.
Right.
And so that's a consideration is, and I know we don't do too much machine control, but if you did machine control, you absolutely have to calculate that into your engineering, because you could put a photo eye there that you're looking to sense product that's an inch away, and it's not outside of that window, and you'll never sense it.
Yep. And the good thing about this type of sensor when looking between the rollers of a conveyor is it actually fans out. So that sensing window there, if you were to look at kind of the way this guy works, if you laid this down like this, see if I don't blows out, that sensing actually fans out like this. Mm-hmm. So imagine your rollers are sitting here. You actually end up with a large window of sensibility here. Whereas if you were to go ahead and mount just this sensor, and again it's conical,
right? Yeah, exactly.
You have a bunch of dead spots.
Right. So you went from 90% of the conveyor width being sensible, and now you only have about 2 inches.
Absolutely.
So on a 24-inch conveyor, you have almost nothing. And so if a box wasn't justified, you're going to miss it every time.
Yep.
Whereas this eye that we're showing now, if the box wasn't justified, you'd see it every time.
Yep. So that's critical and that's why, if I can do just a polarized retroreflective photo eye looking across the conveyor, I'm going to do it, because you end up with a solid line of coverage across the conveyor.
All right. So moving on from background, so we have transmitted beam, which is more commonly called through beam.
Yep.
And you can see there from the picture, it needs a emitter and a receiver. And the emitter only gets a solid power all the time. All it does is shoot a beam. The receiver actually gets the 24 plus and minus plus the output wire. And personally, in the past I've always used through beams when I wanted more precise control on something, and that's not always the exact reason. The other reason is distance. They can shoot much farther than a standard background suppression, diffused, or reflected photo eye.
Absolutely. And then if you think about it, what they did to kind of come up with that, or not come up with it, but essentially instead of both the emitter and the receiver being housed in the same unit, like you said, both of those are housed in separate units. So you have the light being transmitted from one, like you said, that has 24 volts, and then the receiver. And to your point, instead of that being that huge kind of conical pattern like you have coming out of a typical photo eye, it's usually nowadays going to be a laser diffused. So it's a single dot that's a few millimeters wide shooting the stretch of that conveyor over to the emitter side. So if you're trying to catch the, say, leading edge of something where you're applying a label or...
Right, or you want precision, right?
Yeah, real precision.
Precision
Absolutely.
is something that those are good for, and that's what I've thought about. I actually don't know what the... can you go back to the Rockwell document? I want to see... is there a sensing distance 8 meters, 26 feet, right? So... yeah, I mean, right there, and there's 20 meters, 65 feet.
Yep.
And I don't think if you scroll up to the ones we previously talked about, that any of them come anywhere close to that. They don't.
No.
Retroreflective, 14 feet, polarized. You can get up to 49 feet with polarized, which is actually impressive. That's further than I thought it was. But the rest of them, look at clear object detection is 3 feet, and then... scrolling down, let's see the background.
And before we scroll down, I want to point out one thing. If you look at when they're able to get that distance, it's when they actually switch over from the infrared LED to a class 1 laser.
Yep. Okay. Right? And then, so background diffused is what?
Much closer.
20 inches. Yeah, 30 inches is the max, right?
Yep.
And go down to background suppression. Background suppression, look at that.
Yep.
2 inches, 3.9 inches. Like that's in our industry, no. Machine building, yes. In what we do, warehouse automation, conveyors, it's not even up for discussion. If you bought a background suppression photo eye, you probably have your knuckles smacked with a ruler.
You know, I'll tell you one place where I've used this eye before is on a transfer. When, a lot of times on a transfer, it's hard to mount. I think I actually have, if you look at a system such as this, right? Mm-hmm. When product is coming down the conveyor and I pop up the transfer over, I had a diffuse sensor mounted here so I can see when the edge of that case got within 2 inches of the sensor, so I knew it was positionally.
And that you're right. And so that is within 2 inches. Go back to the Rockwell description. So yeah, if you use the background suppression or something, 2 inches, 4 inches.
Yep.
That creates a window that you must be in, and that's the other way to do that is like ultrasonic.
Yep.
And it's much less expensive to go with a background suppression sensor than an ultrasonic, and plus the teaching and the dialing it in and all that stuff. But transmitted beam through beam, 65 feet, and that is definitely the way to go when you want some repeatable, precise distance.
Absolutely.
And then the last one on here that we're only going to touch on because we never used, but it's nice to know that it exists. Basically what this is it's a fiber optic cable that plugs into a standard sensor, and you can actually route that cable into a really tight space for object detection. Never used one, never seen one used, but I could see why machine builders might love something like that.
So is it safe to say that essentially this is an attachment that I could say put on
so if you scroll,
any one of these?
Scroll down. I think they show the attachment somewhere else in this document. Right there.
Okay.
So I'm not entirely sure if that can go on any of them.
Well, it makes sense because you have the emitter and transmitter. Yeah. So this is, okay.
So, but it's really cool. We don't usually have the option to use one, but if I ever got to, I definitely would. So, and so those are pretty much the types of photo eyes that we're going to at least discuss in continuation. And Generally, if we're going to refer to one, our default basic standard is going to be the polarized retroreflective. That's the one we use pretty much 10 times out of 10.
Which is this guy right here.
Okay. And so anytime we're talking about one generically, that's pretty much going to be it. And so the next thing I want to talk about is mounting of the photo eyes and what we do. So like at Pendant, we have our own bracket, and yeah, it's expensive, but there's also some peace of mind with this. And so I don't know if you can see here, you have the reflector. It's really the same bracket duplicated both sides, one side on each of the conveyor, and the sensor gets mounted on one side, the reflector gets mounted on another side, and you pretty much have X, Y, and Z control of this photo eye. So let's say that they mounted it and the photo eye was too high. You just take an Allen key and you can lower that down. And so you do have X, Y, and Z, so you can raise and lower it over the conveyor bed. You can move it toward the conveyor bed and away from the conveyor bed, and then you can actually rotate it on its axis to get to move it leading its position or trailing its position too. And so one of the nice things about this is if they mounted the photo eye directly across from the reflector and you actually needed to put some angle of skew in there, you can do that just with an Allen key. Like I said, they're super expensive, but in our experience, the fixed position mounting brackets, you have to get them perfectly right. You have to align them, and a lot of times the electricians do not pay attention to that. And then you're left kind of holding the bag at the job site when you need to align a photo eye. And so another thing that we have inclusive for mounting is we always supply this 10-degree swivel bracket, and hopefully get a close-up here. So yeah, so like right here, we supply this 10-degree swivel bracket that allows really you to move this photo eye 10 degrees in pretty much a spherical direction. And that makes the alignment process even easier. So you don't have to touch any of these knuckles to move the X, Y, and Z axis. You actually just come in here. You can loosen these two screws up and adjust this by hand. And it makes for a really easy alignment, lock it down. And then if it ever does go out of alignment, the maintenance or facilities technician should be able to realign that super easy. And like I said, it's pretty much the same bracket. So if you use a reflector, they all have the center hole on the back that you see here with the nut. And then they have the same 4 holes on the back that you might see from this guy that we actually use to mount this photo eye. So the advantage over this, Michael, you come from an industry that didn't always use these brackets. Why did you guys start using these brackets at your last
So really,
company?
mostly it was just the ability for us to have one part number that worked in, I'd say, 95% of the applications, because, typically you're going to end up with a right angle bracket that's at one position on the conveyor coupled with a reflector. Yep. And to your point, as soon as you get out to do a control startup or you're going to do commissioning or troubleshooting, you decide you need to move a photo eye 3 inches forward or 3 inches back. And now you have the mechanical team out there drilling holes in conveyors and creating Swiss cheese. And the other big reason we switch to these brackets is because you can mount the base of the bracket in a location and have the reflector sticking out over, say, a motor or a gearbox, say at the end of a sorter, right? We want a photo eye in a specific position. This allows us to get the photo eye and the reflector in that position while as offsetting the mounting base itself.
Right. And so that's a good point. So like these are really pendant specific brackets. They're not generally available on the market for mass purchase from across the country. But one of the things that I like the most about them is when our commissioning agents hit site, just like you just mentioned, if they do need to move the photo eye back an inch or two, it requires absolutely no drill. They don't have to have a 1/4 inch bit to drill another hole through the conveyor, take this out, re-put it in, tighten it down, and then realize, oh man, that wasn't enough. I need another inch, and now they have to do the whole process. They can go there with an Allen key, loosen those up, fold it back some, fold the photo eye back some, and now they've already moved it 2 inches, no problem. And it's super versatile.
Yep.
And at Pendant, we use this bracket for 99% of our applications. The only time we use those fixed position brackets, the standard like 90-degree L brackets that you see, is when we're very limited on space and we just can't get this big bracket in there. But this thing's a workhorse too. If you run into it with a forklift, you're likely to damage the conveyor first before you rip this thing off. So it's very robust. It'll be there in your warehouse a lot longer than most of the other equipment that are installed will be.
Absolutely.
All right. So the next thing that I'm passionate about, having an electrical background, is the wiring. And so, talking about the wiring, the first thing that I want to go over is flying leads or quick disconnect. And at Pendant, we favor the quick disconnect almost exclusively, simply because it makes for the change out of the photo eyes to be very rapid. If the photo eye goes down, your maintenance and facility person simply just need to unscrew it, the cable that is, the photo eye, put a new one in, reconnect it to the cable, and then they are good to go. I think that's one of the places that we invest in the peace of mind for the end user. So at Pendant, we often take the considerations of the maintenance guy or the facilities person who's going to be left maintaining this system after we leave. We take them into consideration because this definitely is not the less expensive way to go. It is the much more expensive way to go because for every photo eye, we're providing a $8 cable. And I know that doesn't sound a lot, but on a job where you can easily have 100 plus photo eyes, that's an extra $800 to $1,000 depending on the quantity of photo eyes. But it's just really that addition. It's one of those Pendant extra mile things that everybody we work with probably doesn't appreciate, but the guy that's left managing the job certainly will.
I would say that there's some additional benefits to quick disconnect as well, such as, a lot of times things get lost when you're sending the big facilities like Department of Defense facilities, Amazon facilities. So sending out a box of cables for the electrician to get wired up before they go into the box with the sensors, or they can get ahead of the game a little bit. They can wire these up. If you need to swap a sensor out, you don't need to have an electrician come at this point, right? So I think, when you think about the big picture of the project, the quick disconnect quickly starts to even the playing field for itself as it pertains to cost.
Yep.
The ease of replacement, making adjustments. You can take your sensor off. You can swap it out if it goes bad, and the electrician can run extra cabling. So I do think, to your point, though, there is extra cost, but I think that's mostly mitigated by the electrical conveniences as well as the ability to swap a photo eye in the field without calling a high-priced electrician to your job site. And since this is what we call M12 or Eurofast, it's also mostly universal. So if it's a DC, say 4-pin M12, it's going to work. For example, that same 4-pin would work for both of these separate sensors.
Right. Yep.
Right. When you get complicated sensors, there are 5 pins, and there are many more, but the common is going to be a 5-pin and a 4-pin. But for our standard, I'm saying I bet you 99% of ours is going to be the 4-pin M12, which is shown on these two sensors.
And so that is something to take into consideration. The two common type of quick disconnects are M12 and M8. M8 is like the mini cable, and every photo I think I've seen is really an M12 connector. That's a standard for like the Rockwell sensors that we use.
Here's the Pico.
So yeah, M12 is micro, M8 is the Pico. Some of them do come with that, and it is And actually, I'm glad you brought that up because it jogged my memory on something too. So you can actually see here uh, the 10 to 30 volt DC sensors in this micro cable. The colors of the cables are brown, white, black, and blue. And if we can scroll up and we see the quick disconnect versions of the others, the cable is red, white, red, and red and black. And so,
In addition to that, you had the dual key
now
as well on the connector itself.
I do see that. Okay, I do see that. I was just going to say that you could use either cable, but I guess that's not true. And really, that's just the color code. Like you don't want like brown, white, blue, black. Those are 24 volt DC color codes, and then the red, the black, and red and white. Those are 120 or higher voltage, 120 to 240 volt color codes. So just make sure that you're matching the sensor with the cable that you're actually using. And our default is the 24 volt sensors. So it's generally you're buying the brown, white, black, and blue cables, and then so not getting too far ahead of ourselves, but you could use, depending on how you're wiring it, is which one of those wires that you use. So brown and blue always plus and minus, and then white or black are your load depending on how you're doing that. So continuing on, I want to talk about and then just comment the flying lead cable. Really, flying leads is just open wires. So you get maybe a 6-foot piece of wire, and then on the end of it, it just has the open wires. You would take that right to a junction box and terminate it with your other cables. So it does not have the quick disconnect capability. So talking about 120 volt photo. First off, let's talk about 24 because that'll make more sense. Then I want to talk about 120, and there's a field caveat there that I definitely want to make sure we go over. So 24 volt wiring, you have two different types. You have NPN and PNP, and that generally is transistor talk for positive, negative, positive, or negative, positive, negative. And that's really how the transistor is terminated to that input and output. And we always wire PNP, which gives us a positive 24 volt signal back to our I/O card. And so in Allen Bradley and every PLC manufacturer, a lot of them are either or, not both. And so you can buy a PNP card and you feed it with a DC minus, and then all of your inputs are DC plus. Or NPN, you would feed it with the DC plus, that's the common, and all of your inputs are DC minus. And so we standardize on PNP. However, other companies don't. So if you're troubleshooting third-party equipment like extendable,
yep.
Right? So the extendable conveyors, there's been some times where we've run into that. And the at Macy's, that's the first one. We wired it up and it didn't work, and we come to find out that the signals in there were NPN. And so we had to put in an interposing relay to swap the signal from NPN to PNP because our cards could only handle one or were wired up. And so I personally don't like NPN, and the reason for that is if a wire becomes shorted to ground, that's as good as a completed circuit and you get a false input.
Yep.
Where PNP, if that output wire becomes shorted to ground, you get a DC power supply alarm and it doesn't trigger the input. However, a lot of manufacturers use NPN because they can ground the chassis and then they can pick that up everywhere that they go. In fact, that was the problem at Macy's with that extendable conveyor. We were trying to troubleshoot how they were getting the signal back to the circuit board, and they ran it through the chassis. And I'd never seen that before, nor do I think that that's good practice. But hey, I guess if you save one wire,
yeah,
that's as good as saving 10 wires or something like that. But that was I would call that a shoddy way to do it.
I heard, I don't know how true this is, but I heard that NPN is much more common in European countries.
I've heard that also.
I'm not too
Or also
sure.
maybe like Japan or something like that. And I would also say that Europe is also, I don't mean this in a, well, screw it. It is a negative way. I think they're stuck in the past on a lot of things. Like when we get machines from Europe and they're done with Siemens, even though we've had TIA Portal since 2010 and it is awesome compared to the old Step 7 version 5 point whatever and before, they're still sending machines out in Step 7 software and they're still using the 300 processor, which I also heard is being phased out. It's actively being phased out right now, so you won't even be able to buy that. And so that would make sense that they still use NPN because that was really the old school way of doing things. I don't much care for NPN or people who use NPN. So if if you're an NPN evangelist, you probably don't have a place here at Pendant. And you're just not going to get along.
Right. But if you admit to being one, you're fired.
Yeah, exactly. Yeah, I don't want anybody telling me how much they like the NPN.
You know what? I always had trouble when I first got into kind of automation. I mean, it intrinsically makes sense to me now that NPN is a negative, signal from the sensor and PNP is positive. But then somebody said to me, well, if you look at NPN, the P is interrupting the N. The N is being switched. And if you look at PNP, the N is interrupting the P. I mean, the P is being switched.
Yeah, exactly.
And when somebody said that to me, I was like, so every time I look at NPN and PNP now, I think like, well, that thing's trying to be all P with it. That N is kind of interrupting it on and off. So it kind of is diametrically opposed from what should make sense, but that's kind of my mental trick to remembering which one's which.
Yeah, exactly.
The P has more P, so it's positive. The N has more N, so it's negative.
So you can look at it as, because the gate really is negative. And if you know anything about transistor, you have like the emitter or collector and then the gate. And so it's positive, negative. So positive input, positive output. Or negative input, negative output.
Mm-hmm.
So, but yes, not to beat a dead horse, PNP for life, right? That's what we're going to go with. And now, and here's what I wanted to talk about this caveat: 120 volt. So I know the sensors say 21 to 260, and I actually think we use these 42 EFs. I think we do use this 21 to 264 volt sensor. Is that our standard?
No. Our standard is a P2JBB. So our standard, they're all the 42 EF.
And that's 24 volt.
Yeah, so ours is the standard 24. So I kind of like these. Whenever I have to do 120 volt controls, I buy these in case somebody accidentally grabs them off the shelf to a 24 volt system. It'll still work if they had the cable.
Yep.
Right. But.
And so these actually don't have a transistor inside. They have what's called a MOSFET, which stands for something like metal oxide semiconductor field emitter transistor or something like that. It's something along those lines, but it's not exactly a transistor nor as good as a transistor because I don't think you can power a transistor technically with 260 volts, 240 volts or whatever. And so I learned the hard way, and I've never actually confirmed this. I was just troubleshooting one time, and it was so ridiculous I had to get on the phone with tech support. But a MOSFET transistor only controls the current, and it actually lets the voltage bleed through. And so your input card needs to see current flow before it triggers that it's an actual active input. But if you were to test the output on a MOSFET at 120 or higher, you actually are going to see voltage on the output side where you will not see that on a transistor. But not enough to
sustain a load then.
Well, it actually limits the current while letting the voltage bleed through. So you could actually see 120 volts on the output, think the sensor's bad, throw it in the trash, put a new one in there, measure again, see voltage on the output, and think, okay, well, now somebody's backfeeding this output wire. And it's not the case. Because it limits, it actually, so like I think a transistor, it limits the voltage and the current because it's practically an open gate where the MOSFET, the voltage can bleed through but it limits the current. And on the input of your PLC, you actually need current flow to trigger that input on. And so that's a caveat that you should look through in the field, because I have thrown a couple MOSFET sensors out thinking that they were bad, and when in reality I was just ignorant. Still am, just not that ignorant on the MOSFET sensor.
What's you get for using 120 controls, man? How old are you?
39. And yes, that's what I get for using 120 volt controls. And so I understand that they're much less costly for electrical installation, but the 120 volt controls are a thing of the past.
One thing I get asked quite often, because you have whether the sensor is going to be PNP or NPN, but then you also have the light out, dark out.
Which we're gonna talk about that next. That's operation. And go ahead and pause it here for a minute. All right. So we are at 40 minutes of video time. We're growing long in the tooth here. So we're actually going to turn this into a 2-part series. So we just went over what is a photo eye, types of photo eyes, mounting, wiring, and we'll come back shortly, hopefully, with operation, common uses, uncommon uses, and NEMA ratings if we feel like talking about those.
On TV time, just click the next video.
On TV time?
Yeah.
What's that? Yeah.
Just click the next video, it'll be immediate.
Now what we need is a cliffhanger, right? That's what we did. What we didn't give the audience that good TV does is a cliffhanger to make you be royally ticked off that the series ended and you have to wait 7 days before you can watch them.
The photo eye would need to explode in my hand for that.
Yeah, exactly.
Is he okay?
Right? Yeah, exactly. The photo eye explodes. And tune in next week, same time, same bat channel, trademark or whatever that is.
See if Michael's dead.
To see if Michael survived the photo eye explosion.
All right, I'll close it right here. See you guys next time.